and these are all for inside the circle, is there's the center, and I draw two chords. This is X, and this is little m, and I'll call this big M. Have you seen this before where two chords are kind of off center, but I give you like the measure of one of these and then the other? You heard of that, seen that?
Not yet, but I believe we're starting that tomorrow.
Okay, great. So you'll be a little bit ahead when you see this here. So X is, and it's again, it's another formula. It's little m plus big M divided by 2. All right. So these are like important things here. Now you mentioned arcs. So we're going to go back and talk about arcs for a moment here. But any questions on what I just threw up at you pretty quickly here on inscribed? I'm sorry, central, inscribed, and then I don't even know what this one's called. Doesn't really matter. Any questions on those?
No.
All right. Okay, so let's just say I gave you a circle and I said, I want the circumference of the circle. Do you remember any formulas for circumference?
Circumference, isn't it it's pi divided by the radii or times the radii?
So pi times diameter is one formula. I don't really like that one as much as this other one, but they're both good. They're both true. 2 pi r, okay. What is the relationship between the diameter and the radius? Do you remember that?
I believe the radius is, I think it's half of the diameter.
Exactly. Or if you like going the other way, diameter is 2 times the radius, right? They're all good. Okay. So if I give you a new formula here, okay, I'm gonna call this the sector formula. It's gonna look a lot like the radius formula. It's an angle at a 360 times 2 pi r. So what do I mean by that? So here's a circle, and let's say I wanted to go all the way around the circle. Well, how many degrees is that again?
360.
360. And let's say the radius is 5. 360 is the angle. At a 360, what does that become? What is 360 divided by 360? 1 times 2 pi r. So notice it cancels out. And let's say it's meters here. These cancel, and this is 10 pi meters. Okay, does that sound okay?
Yeah.
But you might be thinking, well, why would you give me this formula for 360 degrees? Because it just goes to 1. That's a good question. So it's really used for sectors. It's really used for the pizza slice. Okay. Now, side note here, I was watching this documentary last night on a high score, and Pac-Man was actually created. The design for Pac-Man. You've seen a Pac-Man before?
Yeah.
They actually had pizza the day that they were trying to figure it out, and they took a slice out and they said, "Hey, that looks like a Pac-Man." I mean, that simple, right? So the sector here, there's a couple of things you can do with the sector. You can find the length, like the walking distance, okay, of the sector, and that comes from this formula. It's the angle at a 360 times 2 pi times the radius. Let's say the radius is 6 centimeters. Okay, so you have to be able to reduce something like this, like 60 over 360 times 2 pi 6. If you saw this part in the classroom now, this is me asking you maybe to do something here. How would you reduce this? Would you go right to the calculator? Would you try to do something before you go to the calculator? What would you I would
just go straight to the calculator and just put it into.
Okay, so that is fine. But there's two answers they're looking for. There's the exact and the approximation. So if you go right to the calculator, you're giving me the approximation, and maybe that's okay. Not sure. The way to do the exact is to understand that there's going to be a pi in the answer. So you look at everything but the pi, and you put everything but the pi in your calculator. So you have a calculator handy, you said?
Yeah.
All right. So why don't you try that? Put all that in the calculator and let me know what you come up with.
I got 2.
Right. So the exact answer is 2 pi. Now, if you want to go to the calculator and give me the approximation, you're going to put in 2 times pi or 2 times 3.14. But sometimes they want one or the other here. All right. And then there's some units here. Because it's a distance, it's centimeters. So can you punch this into your calculator, 2 pi, and tell me the answer to 1 decimal place, please?
6.2.
6.2 centimeters. Good. All right. So the main formula we're working with right now is the sector formula. Do you have that down in your notes, or do you need a moment to write that down? I'm going to look for some practice problems for us today.
Yeah, I have that down in my notes.
All right. These are harder to make up on the fly, so I gotta grab a quick thing here from the infinite internet. All right. I don't like any of these. So let me make one up here. All right. So here we go. So here is yet another sector. Let's say this is 45 degrees. Let's say the radius is 9 meters. I want the arc length, okay? And that's this S. That's this theta over 360 times 2 pi r. And I want both the exact and the approximation. Could you give that a try for me, please? Actually, let me make this 8. Sorry, make this 8 meters. That'll work out better.
Got 2
2 for the exact.
for the exact.
So the 2 is going to have a pi go along with it. So you've got to add in that pi. And now what are the units? Units are really important here.
I just got 2 on the calculator.
Right, but what are the units here of the
Oh,
radius? What does this M
Oh, 8
stand?
meters. So
Yeah, 8.
18.
Yeah, so that's what I'm looking for here. And then the approximation will be the same. Okay, good. So let me give you another one here to work on. And this time I only want the approximation. Okay. So let me put this one in front of you. All right. So I want the arc length from A to B. Go ahead and work that out and let me know what you come up with.
$7.8.
All right. So I'm guessing you've either seen this before or this is not the issue with your geometry class because there's no issues for what I'm seeing so far today.
This is, we've gone over this before, so I have the general
Okay,
knowledge of this.
got
It's
it.
more towards like finding a segment of a circle and all that junk.
Okay,
It's just finding that.
got it here. So let me throw something else in front of you. Trying to think here. It's easier when I've kind of got something that you've been working on in class. Like if you ever like, okay, these are the notes I took today, or this is what was on the board. That also helps me here. Have you seen some problems where because you mentioned segments inside your skin. So let's just say that's the center, even though that's not really good on the center. But let's say this is this is 6 and this is 8 and this is 3 and this is X. Have you seen some problems like that where you have to find the length of X? Is that something maybe you're thinking?
Yeah, stuff like that. Yeah.
Okay. So the way this works, and in a lot of geometry, you do need some formulas here, is they'll say, okay, this is A and this is B, this is C and this is D, and they'll say that A times B equals C times D. So you have to use that sort of mapping for this here. So what would A be in our problem on the left?
It would be 3.
3. And what would B be?
B would be X.
Okay, equals what's C?
C would be 6.
And D?
8.
Okay, so 3X equals 48. How do you solve for X here?
I think you would divide
Yes.
by 3 on both sides.
Okay, so could you do that for us, please?
3 divided by 3 is 16, and it would be X equals 16.
Right. Yeah, I agree. Okay. All right, so now I'm looking quickly for some other problems for us to work on today. Let me throw something else at you here just to see if this is also related to what you're doing. Do you have a textbook in your class?
I do.
You do? Okay, cool. We'll get to that at some point. All right, so here's a new triangle for you to look, or circle for you to look at. This time they're giving you, what is this called? This distance from the center to the edge?
The central point? Or
This is the center. What about this line segment that
central
goes to?
angle.
Okay, look at, so I'm looking for the word radius, and sometimes I'm
Oh,
unclear
radius.
with what I'm asking for. That's a radius there. If I were to draw this line right here, what would that be?
10.4.
Because it's also the radius, okay? Because it goes from the center to the edge. Now take a look at this line in blue, and I'm only changing colors just to draw distinction of it. What is the name for that?
That is also a, would that also be the radius?
Yes, yes. A little hesitation, but yeah, it is still the radius. Okay, good. All right, now I'm gonna, in red here, redraw this triangle here. So this is a right triangle. You know two sides of the right triangle. How would you find that missing side? You remember that from class or from something maybe in the
Would you
past?
do a squared plus b squared plus equals c squared?
Yes, but to be clear here, let's be clear. Which is A, which is B, which is C, and why? Maybe more importantly.
Would 10.4 be a, 8.4 be b, and x be c?
So A is less than B, less than C, and what that really means for you, what you want to remember is that C is the hypotenuse or the longest side.
Oh,
Okay, it's really important. A, B, and C. Now A and B can actually flip. That's not important, but C has to be
10.4.
that right. Here's one. Yeah. So could you use that information and solve that for X, please? And if you're not sure, I'll definitely help, but just trying to see where you're at here.
Would you just change it to, was it c plus b equals a, or c squared plus b squared equals a squared?
Okay, so yeah, so let's start with the overarching formula, right? A squared plus B squared equals C squared, and good to maybe label, A, B, and C, just to be clear. So we don't know A, it's called X. B is 8.4 squared, and C is 10.4 squared. Okay, all I did was take those numbers and substitute them into the equation. All right. So you're going to square this number. You're going to square this number. And then you want to move this 8.4 squared to the left. Is it clear what I'm asking for or not?
Move it to the left.
I'm sorry, to the right. Boy, that was, yes.
I'm a little confused.
Okay, so grab your calculator and tell me what 10.4 squared is.
10.4 squared is 108.16.
Good. And how about 8.4 squared?
It is 70.56.
Good. Okay. Now here's what I'm asking you to do. To move, when I say move, it's typically add, subtract, multiply, divide. You're going to subtract 70.56 from both sides.
All right.
Can you tell me what that becomes?
So 108.16 minus 70.56 gives you 37.6.
Does. And then what's left to solve for X? How do we undo this square there?
We would square root.
Okay, can you do that for me?
Yeah, we would square root 37.6, right?
That's right. Now, unfortunately, this one doesn't work out nicely. So let's go to like 2 decimal places on the answer there.
6.13.
Good. All right. Now, sometimes you get so like involved in like a little part of the problem, you forget like what we're even doing. So our goal here was to find X, which you can see we have it, right? X is that number we just calculated. X is 6.13. How would we find, let's call this Y down here. How would you find Y based on an earlier discussion we had?
So if we have X, would we just turn it into its own triangle first and then
remind me what that blue represented?
radius? So
you know the length of the radius?
10.4.
Okay. You know the whole thing's 10.4 and part of it is,
oh, we would subtract 10.4.
Yes.
6.13.
Yes. Good.
So that would be 4.27.
You got it. Good. This one didn't have units in it. I just grabbed this from the internet. So, we'll blame whoever wrote it, which we can't. We don't know who it is, but good job on that one. Let's get time for at least one more problem here. I should ask though, any questions on what we did though before, anything on the Pythagorean theorem? I think we cleared up that, A and B are smaller than C. All radii are congruent in a triangle, but any questions on this or anything unclear?
I think I'm getting it.
All right, let's take a look here at this one. So our goal is to find X, which is kind of like what we were doing in the last problem. Kind of, it would actually be like the Y in the last problem.
Mhm.
So this one's more difficult. Just, you got that one right. So why not increase the difficulty a tiny bit here? Any idea how to start here?
So first we need to mark down the radius, which is 16.7.
Okay, and so when you say radius, I'm assuming you mean this one right here, or do you mean something else?
I was talking about just the 16.7, but I'm assuming
This one here.
yeah.
Okay, the radius is 16.7. I'm gonna just label some points here in case that could help you. I'll call that E.
And then we would use the other formula, which is, was it A plus B equals C plus D?
So that's true if we're looking at something where it's off center. There's the center. This goes through the center. So sometimes in geometry, especially, you need to add or remove a segment. And you're like, you might be thinking, well, how do I even know what to add? Well, that's the challenge here, right? Like it's, do you see it or not? So watch this. What is O to A? What's the measure length of O to A?
16.7.
Okay. And what is OEA now? What would we call that?
A triangle.
Triangle. So one of the things I like to do, and if I were in a classroom, I would make students do this because I think it's really useful, is to just draw it off to the side without all the extra, lines and so. So this is 16.7. This is 15. It doesn't need to be to scale. And I'll call that A. Okay. How do we find A in this case?
We would do A squared plus 15, or what?
Yep. 15 squared equals
Equals 16.7
squared.
squared.
All right. So this is actually exactly what we did in the last problem. Do you want to try solving that for A?
Yes. So 15 squared would be 225. And then 16.7 squared would be 278.89. And then you would subtract 225 from itself and from 278.
Yes.
And that would give you 53.89. A squared, that would just be A squared equals that, and then you would take 53.89 and square root that.
Good. All sounds perfect. Give me that number to 2 decimal places.
It would be 73 or 7.34.
Good. All right. Now we got to take a breath here and figure out, like, well, is that actually what we wanted? We just calculated this right here. A, we called it A, 7.34. Is that what we want?
No.
No, we want X. So how do we find X?
We would subtract 7.34 from 16.7.
You got it. You can do that if you want.
And that would give us 9.35.
Excellent. Excellent. All right. So I'm going to go ahead and stop the recording right here.